All right, so this is our third and final day of veteran Onshape. I've had a really fun time teaching all of you, and I guess sort of revisiting / learning Onshape along with you. So real quick, are there any questions or difficulties or topics you'd like me to go over regarding Onshape? Directional arrows. So do you mean when you have the I'll try to see if I can replicate that. I think I know what you're talking about though. So like, let's say I'm So I'm actually not sure about that question myself either. So for the recording, the question was, are there situations where we would need to make our own mate connector versus just using the mate connectors that Onshape generates? I'm actually not sure about that either.
They have like a make your own mate connector. I keep like accidentally clicking it to fasten sometimes. And I'm like, why is it not working?
Yeah, no, I'm actually not so sure about that myself either. Yeah, again, most of the time I work with different programs, so I'm not entirely sure what exactly the rhyme and reason is to make connector one. Maybe if you want it to be visible at all times or something, or yeah, I'll have to look into that and let you know. But I guess what we'll do is we'll look at one of these mates and we will sort of see what arrows we're discussing here. So when you're talking about arrows, do you mean things like how there's those 3 points there, or how do you mean? So I believe those are, for the cylinder at least, I believe those are supposed to represent like the front of the cylinder, the back of the cylinder, and the middle of the cylinder. Axes?
Yeah, like the blue one is the x-axis and the, or sorry, blue is the z.
Red is X and green is Y. Yeah, so those are the 3 XYZ axes, yeah. The 3 points that are kind of forming along there, the 2 white ones and where I have the connector in the middle, are just different points of the cylinder. But yeah, when you have the 3 arrows, it's referring to those 3 axes. Yeah, it's a little bit weird just because, yeah, when we did this in SolidWorks, you literally just select like the face, the edge, the corner of the point, but this one, the axes all show up as well. It's a little bit odd. All right, so are there any other questions? Or I guess, no? Okay. All right, that's fine. I guess one thing I do want to go over real quick then is going to be CAD library. So you might already have noticed that today I have CAD inserter right here. And unfortunately, the reason I didn't originally have you import the gearboxes is because my brain kind of skipped past gearboxes and went straight to the bottom and said, oh, there's no Vex Pro or West Coast Products tab. They must not have it. And yeah, my brain goofed. But I'm going to show you how to get this nice little area over here. So what I'm going to do is go to the App Store, and I'll just do that. There is, yes. So you'll click on this button over here that says App Store. And let me test this window instead. Oh, I guess it's going to show up in the recording. But in the search, you'll say CAD. And here, actually, no, I do need to switch my cast. Yeah. Oh, yeah, just bike seat. So if you click on CAD library, I am going to quickly cancel my plan. Actually, no, you'll just click on subscribe. It's completely free and the tab will show up on your right. And oh no, don't worry, it's like free. And if it's not immediately showing up on your, if it's not immediately showing up in your assembly, then you'll probably just need to refresh and it'll be there. And again, it'll end up sort of right on the side. There will be your 3 buttons for BOM, configuration, exploded views, and you'll see an CAD right under there. And the nice thing about CAD, just to demonstrate, let's say I want to insert, well, you don't necessarily have to do fastener. There's a way to do that here as well, but let's say I want to insert this hub. And let's just pick, actually, no, let's pick a configurable part. Let's pick this bearing. Yes. So it looks kind of like this. The Onshape App Store one is going to sort of have all these parts lying in there, like wheels and a gearbox and motors and belt. And then you'll click on subscribe. And then, yes, you will. So remember to authorize the application. And then everything shows up there. Yep. Yeah, you see, I was looking for Vex Pro and West Coast products. So when I saw Gearbox, my brain was like, no, that's not Vex Pro, just move past it. And I was wrong. But yeah, if you, I think to an extent, yeah, you can, looks like, nice. Yeah. So you'll notice that when you try to insert a configurable part, it'll actually like show you all the configurations you could insert. And here, let's actually, you know what, let's actually insert a gearbox together just to see what that does. I'm actually going to select a different gearbox than the one we inserted. I am going to pick the Evo shifter because I like that name. Oh, here. I guess I'll go for the Evo shifter 3-stage 3 motor, just because and 3 stages. Fancy. I'll say for now keyed, and I can say no motors. Nice. I'm gonna say the Neos. I mean, theoretically, you could do that, right? So I'm gonna say insert, and it'll take some time. It'll put it right into the same assembly. Well, that was like right on cue too. Yeah. Yeah, fully assembled, native to Onshape, so you can actually do more stuff with it. So generally, it's better to mate things in terms of it forces you to think about sort of the relations between parts and sort of grouping. You end up fixing everything, but that doesn't necessarily take relationships into account. So it's one thing if there is only one position this thing needs to be in, or if it's not going to move at all in space. But generally, when you're creating a design, there is a potential for things to move. There is a potential for things to go in different places. So you want to have mates that way you know like what things are connecting with each other. It's kind of like, so for certain parts, it is possible to just create a cross section and then revolve that versus creating an extrusion and cutting out all the little cuts you need to make. And you could just do it that first way where you have this one cross section and that's it, but then that doesn't really tell you what order things need to go in. So part of it's an organizational thing. And there are some cases where you might want to prefer to group things, and that's okay, but yeah, generally you want to work with mates. Speaking of bringing parts into assemblies, let's explore this top tab over here, BOM table. So you're going to see a lot of different things. You'll see item, quantity, part number, and description. Let's add column and see what we can add. So you can actually add a lot of different things like material. You can add unit of measure, name if you have something other than the part number. So I guess let's try adding name. If you, oh yeah, I need to pull this out here. If you scroll to the right, you're going to notice all of these names right here. Neo brushless motor. Some of these are actually going to be part numbers, but they imported as names. So yeah, you can actually do that with pretty much every part that you have in your assembly, and it'll generate a BOM for you. Now, the names are because of that one we imported without using CAD, the one that we imported using a step file. And basically, instead of generating a part number, it kind of just assumed the part numbers were the name. Yeah. Oh, no, that's its own, that always existed. That's all, it's an Onshape, yeah. Normally I like to save it for last just because it's like a detail. But yeah, notice you are not able to add cost per part or weight of individual part, but you are allowed to add things like vendor, material, measured quality, appearance. So this doesn't necessarily give you the complete first required BLM, because again, you're gonna also need the cost and I don't know if you need weight for the first BLM, but yeah, if you're trying to look at a cost sheet, then you'll need to add that on later on. But fortunately, that's pretty easy because you can just go to export to CSV. And when I open it up here, that's not going to show in the screencast either. Let me do new share of that. Oh, neat. I'm going to give that a try. That's a good idea. Yeah, that's the issue there. I'll try cast desktop. Sure. Is that fine? No, yes, it is. So yeah, you'll notice it's not interesting. It's not. That's really weird. All right. Well, let me see if I can. No. Okay. I did. Yes. That's very strange. Or maybe it's just. Oh wait, switch back to cast. It's so strange. It switched back to cast tab. And no, it's still doing it. My screen share is paused now. What? Okay. That's odd. Anyways, you'll see in the tab, I guess I'll show everyone the screen right now. It'll sort of import everything for you. You can remove item if you want. You don't need to keep quantity, part number, description, name. And then you can just add a column for there for cost per part and, do your Excel stuff and it'll populate for you. So, one more thing. So you'll notice that one of these just says part 1, right? Let's go to our part studio and look at that plate. Because there are a few things we're going to do with it. So for one thing, let's right click on parts and say properties. So as you know, I need to redo the screen share. I'm just going to say screen for now. Makes it a bit easier. Yeah. So I guess to show it again, I'll right click on part 1 and say properties. And you can actually do a lot of things. So you can add a description, part number, revision. You'll notice these are the things that are showing up in the BLM. There are certain things you can't change, like the category, but you can say something like gearbox plate. Yeah. Yeah. I wonder how you change that to like complete. Maybe that's like an because I know there's a professional / enterprise thing that adds a few more options. Like in the enterprise option, I believe you can add in things like epoxy and screws to the BLM. So yeah, if I just say like a part number or like an official, like let's say the Jinxers come up with a naming convention, you could have the name of the part and then the part number is your naming convention. And then when you save it, it'll actually show up over in your assembly. You're just gonna have to, yeah, it'll show up right there. Oh, and if you want something to show up first, you can actually click on the column and then just move it to the left or right by right clicking on it. Now, item and quantity you can't get rid of, and I don't believe you can move item, but everything else you can reorder as you want. You can even say right click on something and say exclude from BLM. And then later on, if you want to show it, you can say, oh, sure. How to rearrange them? You right click on the column and then you say move left or right. And you can also click on the item or name and say exclude from BLM. Yeah. Okay, so I'm not sure if there's, so yeah, that's like one of the bigger things I wanted to show you, the BLM and that. Let's go back to the plate really quickly. So before we get into drawings, one thing I do want to point out is if you size the hole holes you create properly for bolt holes, you're not really going to be able to use the hole cutout call out. So I'll show you how to do that. For now, I am going to go back to where I made the holes, these guys. I believe it was extrude 3. Let me see. It may have been, let me check. That's so odd, why isn't it letting me? It might be that. But there we go, now I can edit. So for now, what I'm gonna do is I'm gonna suppress this. I'm gonna suppress that extrude, and I'll show you why. I wanna try putting those holes in using the hole tool. So I am going to hover to the top, and right before you get to the patterns, I'm going to say hole. And there's a few things here that I wanna point out. So as you know, there's different types of screws. Does anyone know the difference between ANSI and ISO in terms of what those sizes end up being? All right, that's fine. So ANSI is generally going to refer to something that you might call like US or like English units. Because I was playing around with it yesterday.
Okay. Mine doesn't come like that.
So assume it says simple. Thank you for catching me on that, Faye. So let's say ANSI. So if you see ANSI, then you'll see all these numbers here. These are just going to be your standard US size bolts. For now, let's do an 8. Sure, 8. You can also change the fit. So yeah, that's going to be really useful. You can also change how deep the hole goes. You can change if it's counterbore or countersink. Yeah, let's do blind. And you can also select sketch points to place holes. So I'm going to select the holes that I just suppressed. For you, it might be slightly different holes. The main thing I want you to practice is like creating holes from the hole tool. All right. Oh, another important thing that you're going to want to keep in track of is you can also change whether holes are clearance, tapped, or drilled. So in my case, you know what, let's say tapped for now and see how that changes things. You'll notice that all of these new options show up as well. So most of these I would not touch except for the depth of the hole itself. The threading I would leave alone because that's generally based off of the screw that you're going to be using. So yeah, again, depth is the only thing I would mess with. Do I have to select the use? If your sketch is suppressed, then okay, so if the extrude is suppressed but the sketch is there, then you should not need to. Yes, you will likely have to make the sketch visible if it isn't. Okay, so I think that means we had a quarter. Yeah, I'm guessing we used a quarter 20 then. Yeah. Oh, and remember that depending on what size bolt you're using, you'll need to change the threads per inch. So for a quarter 20, it'll be 20 threads per inch. For a 1032, it'll be 32 threads per inch. It's going to be the one that says TPI. So it's going to be under, yes, exactly. So if I go to clearance, not all of these options are going to show up. But if I go to tapped, then the threads per inch and the diametric engagement and all those other things will show up. So for now, you don't have to have the exact size bolt that I do. The main thing I wanted to show you was how to create holes using the hole tool. So actually, you know what? I'm going to deselect some of these and have them be different. I'm going to just pick an arbitrary 3 that I'm going to have be different. So these will be tapped holes on the side. And then I'll create another one. And this time I will say countersink instead of simple. And as a heads up, generally for countersunk holes, so normally you're not going to countersink something and then tap into it as well, unless there's like something that goes in between the two. So I'm just going to have that be a countersunk clearance hole. And again, just going to select those sketches. Oh dear. Ooh, that's not what I.
That's a lot of broken.
No, that's not it. Yeah. Okay, so we're gonna do this. I only did 5 because I'm gonna select the other few and then, yeah, I see.
And then what size did you make?
I made them a quarter, I believe, just now. Yeah, so long as you have some sort of hole on there, that will be good enough. So what we're gonna do for the next ones is you're going to make them countersink instead of simple. Yes, and you'll make them clearance instead of tapped as well. So the reason I'm having you do that is so that when we go through the, what's it called? When we go through the drawings, yeah, you'll see. Yeah, because basically for the drawings, hands off.
Yeah, like if you were to put a bolt in, it would like hang off a little bit. Just like.
Oh, I see what you mean. Yeah, that isn't ideal for now because we're doing this for the sake of demonstrating drawings. I'll allow it, but otherwise, you're right, it would not be ideal.
Yeah.
Yeah, generally, this level of hang off would not be ideal, but again, for now, I'll allow it. So now that we have this, one more thing, just for the sake of creating a drawing that we can feasibly look at, I am going to suppress some of these lightning holes because, yeah, that's definitely going to get in the way of some of your, you know, drawing stuff. I'm just going to suppress them for now. It might. More like there's a lot, so having to define each one, if you see what I mean. Oh, I mean, we can try if you'd like. Yeah, so that's fine too. Yeah. Yeah. Again, I'm just trying to keep this simple for the sake of what we're about to do. All right, so speaking of what we're about to do, let's make a drawing of this part. So I'm going to right click on gearbox plate and I'm going to say create drawing of gearbox plate. And for now, I'll select no view so we can set them ourselves. As a note, you can also create a drawing by clicking on this plus sign right here and saying create drawing. For now, I accidentally clicked a little too soon. Huh? Yeah, the drawings tend to be pretty standard. So that's not going to be too dissimilar to what you've done. That's fine. Yes, perfect. So yeah, you'll so you'll want to get top, front, and side view. In some cases, it's not going to make too much of a difference. Like in this case, as you can see, the side and top view are a little bit, well, bland. But another thing you can do to remedy that, I'm going to bring this down here. Yeah, it gets a little bit strange. But one thing you can do so that like emphasize that this is, oh, you just click and drag it. Yeah, you get used to it. Mm-hmm. All right, it's telling me I need to update something, but I cannot find what. But for now, let's say I want to make this view bigger. What I can do is say, so one of the students here said that they encountered an issue where they could only generate one view. So I'm going to say insert view, and I'm going to select, say, isometric, and that'll allow me to choose what kind of view I want to put on. What is going on upstairs? I kind of wonder if the Zoom mic is picking this up. Maybe, who knows? Yeah. Yeah, I've been in classes where Zoom audio that should not have been picked up has gotten picked up, and we're all just like, dude, the professor's telling us about the midterm scores. Not now. Anyhow, let's do some stuff with drawings. So first thing I want to highlight is you'll notice down here, you have quite a few parameters. One that I do want to point out is these guys right here. Can anyone tell me about the box that I just highlighted, what that means? It's okay if you can't. I'm not sure if this has come up in our team before.
Vaguely looks like email, like, or suggest, like, the actions to, like, very precise numbers, or is it like how, like, what you can, like, show, like, measurements of, like, the different dimensions of, like, the sides, and it, like, it's how many decimals you want, maybe?
You're on the right track, actually. So
It looks like something that would do that.
So it kind of has to do with the tolerances. So again, the reason this might not have come up is because like a lot of times teams will just say, okay, if there's a dimension, it'll be to this plus or minus. And that's what these are. So if it's to 2 decimal places, it'll be plus minus 0.05, let's say. Or if it's to 3 decimal places, it'll be plus minus 0.02 or something.
So it's like how much method space.
Exactly. How much method
Like
space?
when you're sewing and you give yourself like seam allowance.
Exactly. That's a really good analogy. So what Faye just said is, I'm not sure if it picked up your audio. So what Faye just said is it's like you're sewing and you try to give yourself some seam allowance, basically how much you're allowed to be off before a part is rejected. And yeah, no, that's actually a really good analogy because at work when I send out machine shop parts, you don't always send out everything with 3 decimal places because that means really high tolerance. It means it takes longer to machine, it's more expensive, you're throwing out more parts. Mm-hmm. Exactly. But if you have too loose tolerances, then if the fit needs to be really exact, you kind of lose that level of precision that you might need. Again, for the team, it's not so important. Yeah, milling is going to be important. Yeah. So yeah, CNC generally, like you would generate G code and then send that out, but yeah, CNC was a good example. So you could change those if you want to be, say for 2 decimal places, I want a tolerance of 0.05, or for 3, I want 0.005. As a note, in some cases, again, I don't think this is applicable to the team, but there are cases where your tolerance isn't going to be plus minus the same number. There will be cases where you can go 0.05 over, but you cannot go under, or cases where you can actually go a little more over than you can go under. So I just thought I'd highlight that because it's an interesting feature. Another one you might enjoy is material and finish. Material, sometimes this just comes from the part if it's specified. Same goes for weight. And then there's also drawn, checked, and approved, which is something you could incorporate into the team if you want. That way, you know, the part has been checked over, the drawing has been checked over, you know this is something you can machine. Yeah, those are the main things down there I wanted to go over. Let's also go. Oh, sure. That's a good question. So for the scale, I double clicked on it and I changed the scale on the side panel. So if I change it to 1 to 3, which is the sheet scale, then it's not going to appear. But if I change it to 1 to 2, it will. And let's just do an experiment here, because right now the sheet scale here is shown as 1 to 3. So if I change that to 2, basically it's the size of that you have scaled this to put onto the sheet. So if your part is 1 to 1, then the dimensions of it on the sheet, yeah. So yeah, so generally you do want to scale something down that way it actually fits on the sheet. So like if you have a 60-inch bar, obviously, yeah, you need to scale that down. All right, so there's a couple of things here that I want to highlight. One of them is
It's like they all like a bunch of like the front and the back like kind of look similar, and so it'd probably be nice for you to like giving it to somebody else to be like this is from.
actually you can, yeah. And I'm guessing Sophie's showing you how to do that. Perfect.
Oh. Oh, it says the view.
Yes. Yeah. So you can say view label, and you can also remove scale label if you want, but yeah, so that's a really good point. Another thing you can do for text boxes specifically, actually, I'll show you giving an example. So the reason I had us modify the plate to have holes is because we can now go over to this toolbar up here and we can say hole call out. And the difference is if we say dimension, it'll just give you the diameter of the hole. Whereas the hole call out will actually give you more. It'll tell you the diameter, whether or not it's through, and that it's a 1/4 through hole. In this case, it's telling you that it's tapped 1/4 through and that is the max diameter. Oh, sure. So I'm going to do that again. I'm going to click on hole call out. It's next to dimension and ordinate dimension. So I'm going to click on that and I'll click on the hole and it'll automatically generate that text for you if you use the hole tool to make it. If you have a hole call out, just generally just use the hole call out because that tells you. Similarly for the countersunk one, I'll click on this hole right here and you'll notice it has different text on it. It says the same diameter and that it goes through, but you'll also notice that it has this little triangle symbol right here and 82 degrees to symbolize the countersink that you have going on. Yeah, so that basically fully defines. But let's say you don't necessarily want to have every single hole call out on here. Maybe you just want to write 2 of the holes on the bottom somewhere and then say like C note 1, C note 2. That gets kind of into text as well. So I'm going to say datum. Oh, not datum. What am I doing? I'm going to say text. Why did I say datum? So datum has to do with setting datum surfaces. So if I say datum and then I set like this as a datum, then that kind of becomes datum A. And the idea of that is basically you're setting that as a reference point. So yeah, in this case, I guess that could be useful. I'm honestly not the best at setting datums. It's generally something that I forget to do. But yeah, the idea is if there's a certain part that you want to reference as like your center, reference as like your top surface, then that's what you could set as a datum. You could have. I just preferred in terms of like having less stuff on the screen for demonstration purposes. You can put it back on if you want. Yeah, actually, let's do that right now. I am going to make a circular pattern of stuff around this hole. So I'm going to say sketch. I'm going to select this plane and I'm just going to, no, I'll just do circles. I want to avoid clutter as much as I can. I'll do it over here. No, stop snapping. Okay, that works. And I'll just, you know, again, you don't have to follow my exact numbers. I'm doing this just for demonstration purposes. Let's do 0.5. Oh, no. We don't want to do that. We want to, it's clipping. That's just, you know, actually, you're right. That's a little too much clipping. Let's go back to 0.6. There we go. It is a snowman hole. Anyways, now we're going to do a nice little revolve. Circular pattern, we'll do that. And we'll drag the center to here. And we'll do 5 of those. And actually, I'll avoid the clipping because I can. I'll just see if it's 5. And then that. Oh, and be careful for your circular patterns. A lot of times it'll default to going onto the origin and you can drag it to whatever point you want. As long as it's like, so like in my case, it ended up here. And what that means is it's going to think that I'm patterning around the origin when I'm actually trying to pattern around this. So for now, I'll just have that as my pattern and I'll extrude that. Again, I'm going quickly here because I just want to demonstrate a thing real quick. And I'll say through all. And now there's a whole pattern around there as well. So if I go to the drawing, I can click on this yellow circle to update. And it'll take a little bit of time, but it'll update. So as you can see, this might be a little bit of a problem in terms of dimensioning, just because you're going to have a lot of dimensions in one tight space. So a nice thing you can do is going to be something called a detail view. So I'm just gonna, I started at the wrong point. Whoops. I will do a detail view. I'll start right over here on the center, and I'll kind of drag out. And then I can create this detailed view and sort of put it over here. Yeah, and then, yeah, exactly. It's a magnifying glass, and it's really useful when you want to show a specific part, but you don't want to put all the dimensions in one area. So again, I'm not sure how useful that will be on the team, but it could be useful. And again, it's a good way of making sure that you don't get overwhelmed with dimensions in one specific area. And a good way to handle these sort of pattern type dimensions is we're going to do something called, not geometric tolerance. I am looking for my point. Sorry, I have been using Creo all day and my brain is kind of fried a little bit. So I'm going to say center mark for now. And I can actually select these centers and sort of show center marks there. And I can also create reference lines. So I'm going to say 2-point center line. I'm actually going to say 2-point circle center line. And I can sort of select that center point and then go out to here. And instead of saying each circle's dimension, what I could do is, where is it? There's a call out button. Sorry, my brain's kind of toasted today. But there should be a way of just adding a note with, wait, yeah, there was a symbol I was going to show you all to use earlier. Like the call out one. I guess that could work. Yeah, I guess that works. Oh, no, it doesn't. Yeah, right. That's for if you have a BOM. All right. I guess I'll see if I can find that later and add it on in. But basically, what I was going to do is like have an arrow sticking out and then say 5 holes equal space.
It's next to the big,
yeah, it's the magnifying glass, but I think that's specifically for a BLM. Because if you look at it, you click, and then table item number. So you need to mention what it is in the table, and yeah, that gets to be a thing. Useful for assemblies though. So the general idea is for callouts for what part of an assembly it is, you would say like the part number it is in the assembly and then the quantity that you're going to need. So I guess what I could do instead is say for now, C note 1. And I'm just going to make that a bit bigger. Ah, it went away. I keep forgetting that sometimes the escape just completely deletes it. So I'm going to say C note 1. And I'll hit the check mark. And then over here, I'll create some notes. And I'll create a numbered list for now. Why not? And I'll put a note saying 5 holes. I forgot what dimension I said. I think it was 0.25 inch diameter. And I'll say equal spacing. I'll still need to dimension, I guess I'll say, I think it was 0.75 inches from center. And this is one of those things where you probably should check in. Again, I'm thinking it might be good to like have a meeting with mentors to decide like how exactly we want to do drawings and like what standards we want to apply coming into build season, not just because it would be good to have that discussion, but also because we want to make sure everyone's on the same page. But yeah, those are some basic things you can do with drawings. Does anyone have any questions so far? No? Okay. I think we're actually.
I'm gonna check how much more I found than I was before.
Huh?
It's only 4.
Yeah, I know, we made good time.
Posted about why the UES. This is like the 3rd class notification I've gotten.
Oh,
That's like sign up for one of UES.
that's so wholesome. Yeah.
Yeah. Well, the whoever runs like our class of 2022 like Google Classroom posted it, so like all of the seniors were alerted, And then, like, they post about it, like, it's like, what? Miss Morales posted about it in our math class. Like, well, yeah.
I'm
I
just,
mean, people like tell us about it.
I'm just excited Miss Milanovic and Miss Murad are still here. They've been here a while and I'm just really happy. Yeah, so I think the one last thing I wanted to go over with you was the exploded views, but after that, I guess we could discuss a few things. So exploded views. For now, I'm just gonna hide this Evo shifter here. And it said something was a problem. Let me edit that. I think I did something kind of weird. Huh, I see what happened. Something rotated. Okay, I see what happened. Nice.
Just like random and new people, or? Oh,
Nice. All right, so I guess we'll go into exploded views now. So you'll need to go back to your assembly. And for now, I'm going to say suppress the gearbox that we added in. This is actually going to be the last thing we go over today. And after that, we can just open things up to discussion and feedback and sort of reflection. Because we are actually making very good time today. I'm surprised. I think it's because everything we're doing today is like one thing after another, but they're not connected. So if you fall behind a little bit, then like you can just, yeah, exactly. Yeah. All right, so I guess just let me know when you're ready to add an exploded view. Oh no, exploded view is going to be in the assembly. Yeah, so exploded view does not have that many purposes, but it's really good for like visualizing the order in which things get assembled together, and it's good for like visualizing. Oh, I suppressed it. Yeah. Yeah, that's probably the part studio. Yeah, because we did just modify the gearbox plate.
No, I was saying like for the Evo shifter.
Could be. So for now, I'm gonna, here, let me delete that. So I'm gonna say add exploded view. And now I'm gonna take a look at all these parts we have here. And you'll notice that when you have an exploded view, you can click on something and then just sort of pull it away. You can kind of pull it up if you want to, but I just clicked on a part and then I pulled it away. And you'll notice that if you click on multiple parts, it'll pull them away, but together. So be careful about how you select. So in my case, I'm going to select this gearbox plate and I'm just going to pull it out there. I'm going to select the check mark. And I think we'll leave these two bearings alone for now. And I'll select these two shafts and just sort of pull them out a little bit from the bearings. And as you can see, it's kind of subjective, you know, it's up to what you think would be a good means of viewing this. So sometimes you'll see it as a side view where everything is sort of pulled apart from each other, if that makes sense. A lot of times you'll see it also as isometric, where it's at an angle, but you can see each individual component. So that's kind of the intent of exploded views. It's a really good way of sort of looking at something part by part and knowing sort of what goes into it, what order things are in. Yeah, that's the main purpose. It's more of an aesthetic thing than anything, but it's a good skill to have. So I guess everyone let me know when you have some sort of exploded view. And after that, we can sort of get into the reflection of this.